Hey guys, Andrew back again, and in this video we're going to start breaking down looking at our IP addresses. So we talked about IP addresses, we talked about subnet masks and their scope and their ranges, right? I mean different classes. So we're going to start taking a look at actually subnetting and breaking down our IP addresses on their octal boundary. And again, when I say their octal boundary, I'm just saying this is an octet, right? We have 8 bits here at 192, 168, 42.11. Each of these dots represents a boundary of a full octet of 8 bits, all right? So when I say octal boundary, I'm just talking about breaking down subnetting on these clear-cut lines here, all right? And not moving in and out of them. We'll get to that eventually. But for now, I wanted to introduce this subnetting here and a very new important thing, and that is this ANDing process, okay? So we have this process here, and it's called ANDing. ANDing, all right? And what we're going to be doing is we're going to be comparing our binary values. So we're actually going to convert this 192.168.42.11 based on its subnet mask. All right, so we're going to go in here with the subnet mask in a bit here, but we're actually going to convert all of this to binary. Now I'm not going to go through the whole table process. I'm just going to say go back to videos prior to take a look at how, if you can't remember how, look at breaking these down. Now, the only real difference here is in the past I just gave you one value or one number, or maybe just a few values, a few numbers. Basically, you're going to take each of these octets, break them down one at a time, and get the binary for 192, 168, 42.11, and just works through it step by step, and you'll get the entire binary value of this IPv4 address. All right, but once we get all those values, we're going to need to go through some type of ANDing process. All right, so this ANDing process is just a basic logic table, and what it's going to say is based on one input A. Usually it's denoted as there's an input A and an input B. Based on the value of two inputs, we're going to get some output AB. Now I've made it a little bit easier for us. Instead of denoting this as AB and AB, we're going to say we're going to grab the each binary value of the IP address here, compare it to the next binary value of the subnet mask that we're going to derive, and we're going to get our network address. We're going to get the address. This is a special address that's going to represent all of the different devices, or essentially the network that we're operating in, okay? So in an ANDing table, anytime we put a 1 value, because again, this is binary, so we have zeros and we have ones. Anytime we put a 1 in, and another 1, so we have a 1 on our IP address and a 1 on our subnet mask, our network address binary value is going to output a 1. Any other combination, whether it be a 0 and a 1, or a 1 and a 0, or a 0 and a 0, we're always going to get a 0 output, okay? So if we have a 0 from our IP address, again, the binary value, and a 1 inside our subnet mask, we're going to get an output of a 0, all right? If we flip that, we get a 0 and a 1, we're going to get a, it's not a 1, okay, that's a 0, all right. And finally, if we have a 0 as an input here and a 0 as an input here, we're going to get another 0, all right. So we're going to leave this table here, all right. And remember in the last video, I kind of hinted at this. We got another rule up here, and that's if there's ever any 1s in our subnet mask. So this is rule for subnet. Let's see if I can squeeze this up here. Subnet. All right. Subnet rules. All right. Anytime we have a 1 in our is going to represent a network bit. All right. A network bit. And anytime we have a 0, all right, it's going to represent a host bit. All right, so let's actually take this this number here, this 192, and I'm going to try to keep it color-coded here. Wrong color. All right, and we're going to break this down into binary. So I've already got this written out here. So 192 is actually 1, 1, and then 6 zeros. So 1, 2, 3, 4, 5, 6. I'm going to try to line it up as best I can here. 168 is 1, 0, 1, 0, 1, and then 3 zeros. All right, 42 should be 0, 0, 1, and then 10 in binary, 1, 0, 1, 0. And then finally 11 is 0, 0, 0, 0, 1, 0, 1, 1. All right, did my best to squeeze it in there. All right, so that is our IP address. This is our IP address in decimal, right? And then we can convert it out to binary. So now that we have that value, let's grab our subnet mask here. All right, and our subnet mask is /24. So we can actually kind of do the binary first and then work our way back. All right, so if I line this up, I'm going to do my best here, and then we're going to say we have 24 ones. So like the last video, I said we have a 1, 1, 2, 3, 4, 5. Let me try to get this. 6, 7, 8. Oh boy, I'm way off on that. 1 second here. Let me try to get this as close to lined up as possible. And when we get into it, you're going to see why I want this as lined up as possible. Okay, try that again. So 1, 2, 3, 4, 5, 6, 7, and 8. And then we got 9, 10, 11, 12, 13, 14, 15, 16. All right, getting close. 17, 18, 19, 20, 21, 22, 23, and 24. And we're all out, so 1, 2, 3, 4, 5, 6, 7, 8. Okay? Our subnet mask, right? And if I have all ones in binary, that is 255. All right? Dot 255. 255, 0. Okay. So why did I line this up as perfectly as possible? Well, the idea here is, remember that this is our IP, right? Or our A column. And this is our subnet mask, or our B column. So our output, our AB, all right, so to speak. So where that's a B. Let's get that out of there. There we go. AB, right, is our network address. All right, so we're going to need to get an output, what's going to be our network address. All right, so we're going to go through and we're going to do this one by one. Now, as you get faster in time, you really don't have to do this one by one. You're going to really be able to speed this up, but just for the first time, we'll take it one bit at a time. All right, so we're literally going to compare this bit here to that one there, and this one here to that one there. And we're going to do that all 32 times. You ready? Let's go. All right. So just to memorize this, anytime we have a 1 and a 1, we're going to get a 1. Any other combination is always going to be a 0. All right. So we have a 1, and a 1. So a 1 here, and a 1 here gets me a 1 in my network address, right? A 1 and a 1, a 1 and a 1 gets me another 1. A 0 and a 1 gets me a 0. And then I have that 6 more times. So 1, 2, 3, 4, 5, 6. 1, 2, 3, oh, no, I can't count. 6. Okay, moving on to the next octet here, right? So in a 1 and a 1, a 1 and a 1 gets me a 1. A 0, and a 1, right, gets me a 0. A 1 and a 1 gets me a 1. A 0 and a 1 gets me a 0. A 1 and a 1 gets me a 1, and then 3 more zeros. 1, 2. You can start to see the pattern here. Do I really need to keep going? Right? You can start to see the pattern where anytime you have a 1 in your subnet mask, all right, and you have a 1 in your IP address, your output's going to be a 1. Any other combination is always going to be a 0. So as long as we have 1s in our subnet mask, it's plain and easy for us to see that it's going to be a copy of what you have in the IP address. All right, but we'll just keep on going here. So this is a 0, that's a 0, right? We get a 0 and then a 0, a 1, right? Boop, right, boop, right there. Okay, a 1, a 0, that's a 1, 0, 1, 0. All right, so, all right, we've seen this pattern, but now, right here, our subnet mask has changed. It's no longer all ones, right? Because our rule is going to say, hey, look at this. A 1 is a network bit and a 0 is a host bit, all right? And we can really see that now where this is going to represent the network portion of our address. This is the street we live on, right? And this is going to be the host portion of the houses, each of the different houses, right? So we have a 0 and a 0, right? We're going to get a 0. And then again, we got another 0. We got 4 more zeros here, right? But here we are on this, I got this right, 1, 2, 3, 4, 5, 6, 7, 8, yep. So a 1 and a 0, so I got a 1 here, but now I got a 0 in my subnet mask, so my output is going to be a 0, all right? And since all I've got is zeros in my subnet mask, everything else is going to be a 0. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we have the binary equivalent of what the network address is, the special address that represents all of my devices on the network. This is this address down here is the representation of all my IP addresses that exist here in this network of 192.168.42.0. So what is this network? Well, you can just take this binary value and convert it to decimal, which will be 192.168.42. And it's not 11 anymore, it's all zeros, so it's 0. So the network address is still /24, right? The network address here of the given IP address is 192.168.42.11, all right, /24, right? And the given network where this .11 here exists, it belongs to the 192.168.42.0 network, okay? Now, moving forward, we're going to have some different addresses that might be reserved, but we're always going to be looking for this network address to define where the beginning of our network is, okay? So in the next video here, we're going to start taking a look away from just the network. We're going to still find this network address, but we're going to find more than this network address. We're going to find the broadcast address. Now, I've talked about broadcasts before, right? We have unicast, multicast, and broadcast addressing systems, these different communication systems. Like I broadcast a message out to a group of people, and anyone that's listening can tune in, and anyone that's not, well, they're going to hear it anyway, okay? So we're going to broadcast, right? And we have different protocols in Internet Protocol version 4 that use this broadcast traffic, all right? So we're actually going to define the last address in the entire network, this entire network, wherever that is, right? We're going to find out what the last address is. And we are going to then, that last address, that absolute last address is going to be our broadcast address. So we're going to reserve those, right, moving forward. And then we're going to actually figure out, where's our range of addresses that we can use? What can we actually use for our computers, our printers, our phones, and whatever else we have on our network, okay? So we're going to check all that out in the next video. I'll see you then.